All right, good afternoon, everybody. As I was introduced, my name is Evan. I'm the product manager for Programmable Wireless. Can I get a real quick show of hands as to how many people were here last year for Signal? Okay, so pretty good number. And you probably remember that at the keynote of last year's Signal, we had a demo where we had a bunch of little wearable balls that all lit up, and we did a few voice demos and things. But we were introducing a product called Programmable Wireless. And that was an announcement at the time. We very quickly opened it up and let a few customers in to start previewing things. And then earlier this year, we actually launched the product into beta, so it's now available to everybody. And I want to make this not a sales pitch, not trying to oversell anything or overdescribe anything. This is a product that exists today. It's in beta, and I want to make this a really matter-of-fact sort of conversation about how the product works, what the functionality is, what you can use it for, why we're excited about it from a use case perspective, and just sort of hopefully share a little bit philosophically about how we're thinking about the product. So to remind you about what Programmable Wireless is, we describe Programmable Wireless as developer-first cellular connectivity for IoT and communications. And we're going to break down those two real big use case categories in a minute, the IoT and the communications. So we have about 30 minutes, and then we have a break afterwards. That means that I'll be hanging around here. I'm more than happy to have conversations with folks to dive further into roadmap. I'm really excited to learn about the use cases that people want to build with the product. So if you would do me the favor of hanging around and chatting with me afterwards, that would be greatly appreciated. But between now and then, we're going to talk a little bit first about use cases, those two use case categories I mentioned, IoT, in particular wide area IoT, which is really where we're playing with this product. Programmable communications as it pertains to this product. I'm going to give you an update on what we've been doing for the last 365 days, and then talk a tiny bit about the roadmap. I'm fairly passionate about the roadmap for this product, so I really have no problem sharing details about it, and I think that you'll agree we're probably in the right direction, but that's kind of it could be an extended discussion, let's say. So I'll give you the highlights. The most important thing I want out of that is that if you have a problem that you're trying to solve, or your customers have a problem that you're trying to solve, and you don't see that problem being solved by the product that I show you immediately before that, I want you to come and talk to me about it afterwards. Because we're not just thinking about 3 to 6 months, although we are thinking about 3 to 6 months, we're also thinking about 1 to 2 to 5 years as well. So I want to make sure that I understand all the problems you guys are trying to solve. So let's talk about wide area IoT for a minute. I think particularly with the developer audience, when we talk about IoT, there's some degree of confusion as to why we're talking about cellular connectivity. When a lot of us think about IoT, we think about light bulbs and toasters and things that live in your house. And admittedly, I kind of do the same thing a lot of the time. And that is a massive category of devices. There is a massive category of IoT devices that will probably never be connected over wide area IoT. And when I say wide area, I mean big public networks that are used by multiple entities, as opposed to the wireless network you run in your office, the wireless network you run in your house, the Bluetooth network that you run on your body. I'm talking about big public wide area networks. So I want to talk about what is the role of these networks in IoT, what are the technology options, and how is this going to change to better support IoT? And that's a conversation I'm really interested in because I think it really will give you an idea of why we think this is such an important product. This is the worst slide in the world. It's one of those slides everyone shows when they talk about IoT. It's all about the hype, all about the hype, all about the hype. The reason I'm showing it is not to show you about the hype for how many IoT devices there are going to be, because we've all agreed there's going to be trillions and trillions. It's actually about the disconnect between this number, say 10 billion, 11 billion, 20 billion, and this number. So this is the number coming from from ABI Research, which is a leading research firm, on how many of those IoT devices will actually be connected via cellular connectivity. And you'll see that by 2021, this is actually just getting up to about 1 billion. So of those 20 billion devices that we're predicting that about 1 billion of them are going to be cellular connected. This, I think, is a conservative prediction. I think there's a lot of things we can do to bend this curve upwards. But before we talk about that, I want to talk a little bit about the state of the union right now. So the customers that we have, early customers that we have for this product in terms of wide area IoT, can be summarized into a fairly distinct set of use cases. And the thing I want you to think about as a pattern here is that these are high value use cases. So think about the value in terms of the ROI that you're and the investment that you're then willing to make to connect these devices in a wide area manner. So we have asset tracking, we're tracking trucks, cars, shipments, industrial monitoring, we're monitoring oil pipelines and gas pipelines. Automotive is probably the largest by revenue individual category for wide area IoT today. Security and surveillance, smart city, agriculture, commercial and home infrastructure monitoring, wearables and healthcare. But even the wearables and healthcare use cases that we see today for these cellular connected IoT products, it's not your standard wearable product. It's things like iBeat that you saw on stage this morning, where it's literally life and death. Like when you're talking about high value use cases, this is monitoring somebody's cardiac situation. So all of these use cases are fairly high value, whether that means it's a premium product or it's actually making money, or it's doing massive loss mitigation in terms of thousands to millions of dollars. These are all pretty high value use cases. And there's kind of a reason for that. Or I shouldn't say there's a reason for that, but there's a reason that this might have emerged as the situation. So you look at the technology landscape for wide area IoT today. And there's sort of three categories of connectivity that we might talk about. So there's 2G and 3G, and then there's a couple others that I mentioned here, Sigfox and LoRa. There's actually a whole bunch of others that are sort of in the category of Sigfox and LoRa, but those are two kind of leading. 2G and 3G, so everyone's familiar probably with those terms. They're just cellular connectivity technologies. Pretty good throughput, pretty poor battery life in the scheme of things. The module cost. So what is a module? Module is essentially the thing that you buy that you put into your IoT device that you're building that interfaces between your microcontroller or your microprocessor and the chipset that is connecting to the radio network. So it handles abstraction of GPRS sessions and IP and things like that. But just think of it as like the necessary thing you have to buy to deploy with this technology. So module cost for 2G, 3G is pretty cheap, $3 to $10. The reason for that is not inherent to the technology. It's just that these chips have been manufactured now for a very long time at very high scale. And it has really good availability. It runs in licensed spectrum, but across the world, the spectrum that different operators use for 2G and 3G is actually pretty similar. So a quad band radio for 2G or 3G is probably going to allow you to do almost a worldwide deployment. Sigfox and LoRa are kind of different. They're what we call low power wide area network technologies. They are, you go from a battery life, these battery life metrics, by the way, these are based on 2 AA batteries. So imagine a device that's not doing anything else, it's just communicating with the network with 2 AA batteries, and you're talking about going from hours to days of battery life to 20 years, 10 years of battery life. So these are true low power wide area network technologies. Both of them run in unregulated spectrum, although LoRa has been deployed in licensed spectrum. The module cost is pretty low. The battery life is very good in both cases. And the speeds are pretty low. The reason the speeds are pretty low is because they run in unlicensed spectrum. So they run, for instance, as an example, in the 2.4 gigahertz spectrum, which means that you have a lot of noise in that spectrum. The other thing about these technologies is that they are, so LoRa can be deployed by anyone. Some operators are deploying it. But it's also, there's private deployments. There's a really great blog post about some folks who rolled out a LoRa network in San Francisco. It was really fun. And Sigfox is actually a commercial entity. So it's a network and it's also a company. And they roll out that technology city by city. And I think actually the limiting factor, there's an argument to be made that the limiting factor of those two technologies is actually that last part that I mentioned, is that they have to be rolled out city by city. But there's something that's really interesting that's coming down the pipe for wide area IoT, and that is LTE. So we're all actually pretty familiar with LTE, but you probably think of LTE, actually that sounds really condescending. Some people probably think of LTE as the thing that's like in the Verizon ads in the Super Bowl, which is like, the speedometer that's like bending over, oh my God, it's so fast. LTE is actually a big category of technologies. So the LTE that's probably in your phone is probably LTE category 4. It's very high power, it's very complex, it's very expensive, and there's not many companies on the planet that are actually sophisticated enough to build really good antennas for it. There's LTE Cat 16, the Samsung Galaxy S8 will be the first phone to come out with LTE category 16. That gives you gigabit speeds when you're driving down the freeway. So these are really complex technologies and not required for most IoT use cases. There's also another technology called LTE Cat 1. This is the technology we recommend to most customers today. The reason is it has very similar performance characteristics to 2G and 3G. It's a little bit cheaper than LTE Cat 4 because the relative complexity here is compared to LTE Cat 4. So LTE Cat 4, you pay $40 or more for a module. LTE Cat 1, you might pay $16 for a module. And it's an immediate replacement for 3G. The main advantage over 2G and 3G being that it is not going to be sunset. So the operators are looking to sunset 2G and 3G spectrum at basically as quickly as they can because they need to reuse that spectrum for higher revenue use cases. But the technology we're really excited about is actually a category of technologies, and there's a few not competing standards, they're all LTE based, but there's a few standards. One of them is really synonymous with this category of technologies called NB-IoT. The full name actually is LTE Cat NB1. And these are really, really simple modules, really simple modems, about 10% of the complexity of Cat 4. The maximum throughput is about 150 kilobits a second. Battery life is about 10 years, so we're getting into that low power wide area network sort of family of technologies where all of a sudden, deploying a parking meter, if there's no power available, it doesn't really matter. Just come back every 10 years and change the battery. And they use really small amounts of bandwidth. So it's the reason it's called narrowband is it uses about 180 kilohertz band to actually communicate in of radio. It's indoor optimized. You can get about 50,000 devices on a single cell tower. But in my mind, the biggest advantage of all of these over the previous slide, the LoRa's and the Sigfox's, is that you already have operators all over the world that have these networks. They're already built, right? So you already have towers, you already have backhaul, you already have mobile core networks. So there is a little bit involved in actually rolling out NB-IoT, but for some operators, it's just a software upgrade. So instead of having to wait for some company to go and deploy in every place you want to operate, and they may choose not to deploy, for instance, in rural areas, in this case, it's going to be more of an operator decides to roll out NB-IoT, and all of a sudden, it exists for the scope of a country. And that's one of the reasons we're really bullish about this technology. In terms of module cost, we think these modules are probably going to start at about $6, but expect that to come down quite a bit, like 2G and 3G has, over time with manufacturing scale and all that kind of stuff. So we're super bullish on this. We think there's a ton of really, really interesting use cases for the existing technology, for LTE Cat 1, for instance, and I showed you all those use cases before, but we think this is really, really super interesting. And I spent a lot of time on this slide. We actually think if we work really hard and the adoption of those low power wide area LTE technologies is very good, and we can work together as a community and as a company to educate developers on how to very quickly and easily build and deploy solutions for that go out and make money and build businesses, that we actually can probably bend this curve a little bit. So what you start to think about is you start to think about more technologies that you previously might have considered as being candidates for Wi-Fi or some other sort of local area network, being candidates for wide area networks. Because why not? The configuration barrier is lower. You can log into it remotely and fix it if someone's Wi-Fi network's down. There's a whole bunch of reasons that these technologies are superior. And if that cost comes down and the battery life goes up, we really think this is going to be pretty interesting. And I should say that the SIM card is exactly the same. So if you're getting ready or you want to take advantage of this trend, going out and shipping an LTE Cat 1 device today is a really good way to get yourself ready for a world in which technologies like NB-IoT exist. And I should say these are not far off. These low power wide area LTE technologies we're talking end of this year, sort of beginning of next year. There are some operators murmuring about having things out already, but I'm yet to see any sort of real working example with any real commercial sort of use case backing it up. So that is cellular IoT. Another group of use cases that we support with Programmable Wireless is communications use cases. The use cases that we're initially targeting for communications are, I guess I would describe them as non-primary communications device use cases. So we have a lot of customers that facilitate large groups of delivery people, right? You have an on-demand service worker or group of workers, and you want to make sure that they can only make phone calls to the person that they're going to drop something off to right now. But you want to give them a device, and maybe you want to lock down the data connectivity as well, so they can only access certain things. You want to make sure they're not streaming Netflix. You could even enforce rules like, if they're currently driving, don't let them text, things like that. So these kind of like high-value, domain-specific closed loop to an extent communications workflows, maybe point of sale, chatting with customers, calling customers from point of sale. One that comes up all the time is like there's all these types of commercial environments where like hospitals and like construction sites where people aren't allowed to have their phones, but until now, the way that they've communicated with each other is with these like really expensive point solution type push-to-talk devices. And people are realizing like with programmable wireless and with a $50 Android phone, I can replace that. So this is the type of communications use case we're targeting right now. Whether this will evolve in the future, I'm sure it will, and we're excited for that future. So now I'm going to give you a little product overview. So hopefully that was informative in terms of the industry that we're going after. Let's talk a little bit about the product. This is our demo I mentioned from Signal last year, and as I mentioned also earlier this year, we opened up the product for everyone. We're really happy with how things have come out. We think we picked the right battles in terms of the features that we wanted to really focus on early on. And I'm just going to walk you through them. I'm just very matter of fact, this is all stuff that's available today. Just to remind you, developer first cellular connectivity for IoT and communications. Okay, so the things that we have SIMs. You can come to our website, you can log in, and you can order SIMs. Anyone can order SIMs. There are two types of SIMs that you can order from us. Actually, there's not. There's one type of SIM packaged two ways. You can order a SIM starter pack. This is 3 SIMs in a box with a book of inspiring things. The difference between starter SIMs and regular SIMs is these are not pre-allocated to an account. So you can buy them, you can give them out to your colleagues, and you can all go and register them on your Twilio account and start building. You can also order bulk SIMs. So if you order more than 10 SIMs at once, we can just put them on your account before we ship them. And what that means is that you can configure them via the APIs before they arrive to you. So if they're going straight to your production line, by the time they arrive and get inserted in the device, they'll be configured appropriately. So those are the two types of SIMs. And again, I keep saying two types, but I think you know what I mean. Those are the two methods by which we distribute SIMs. We have a usage API, so you can query usage on your devices for data, for SMS, for voice, and you can do that globally. We have what we call our commands products. Commands is machine-to-machine SMS. Now, as you know, Twilio has been focused on SMS for a long time, and we have a very mature messaging product. This is slightly different. So it's very similar, but it does things in a way that are a little bit more machine-to-machine centric. So for instance, you don't need phone numbers. There's no need to use a phone number. You don't need to buy a phone number to send a message, and you don't need to know the phone number that actually exists on the SIM. You just tell us, send this message to that SIM, and on the flip side, when the SIM sends a message to a certain pre-allocated number, we webhook to your code. There's a few other differences. It's a little bit cheaper than our regular messaging API. And two other main differences that we allow you to send binary SMS so that you can just send straight up PDU encoded bytes of data, which is not really particularly useful in like our traditional conversational messaging product, for instance. We're also shipping a feature in the next few days here, which is the ability to expire messages. So you can say, send this message to the device, but if it hasn't received it in 5 minutes, don't send it. So just things like that that are a little bit more machine-to-machine centric. We have the ability for you to create rate plans. Rate plans are essentially just defining capabilities. Can it use voice? Can it use messaging? How much data can it use? Can it roam globally? Can it roam onto other domestic networks? You create 1 rate plan, 2 rate plans, 10 rate plans, and then you put as many devices as you want onto every individual rate plan. And each of those SIMs will inherit its capabilities that are defined on that rate plan. One of the things that you can choose on this rate plan, and this was I don't want to say this is something I'm really proud of, but I am really proud of this because this was a huge amount of engineering, and I really like the way it turned out, is you can choose between pooled and individual metering for your SIMs. And what that means is that if you choose pooled metering, all of the data that all of your SIMs use will be added together, and you'll be billed in 100 kilobyte increments priced per megabyte. So what that means is that there's no what we call breakage. You pay for exactly what you get. And that's really good for when you have a very large fleet of devices that might only be using 2, 3, 4, or 5 megabytes each a month, which is very common in IoT. You can also choose what's called individual metering. And in individual metering, this works more like a regular cell phone plan, which is that we meter each SIM, and we measure its data usage that it uses. And we essentially reduce the price per megabyte on the assumption that you're paying in blocks of 250 megabytes on a per SIM basis. So if one SIM uses 200 megabytes and another SIM uses 200 megabytes, in the pool plan, you're paying for 400. In the individual plan, you're actually paying for 2 blocks of 250. But overall, the price is going to be lower anyway, depending on how many devices you have. So basically, this allows you to just optimize between, am I deploying a really large fleet, or am I deploying 2 or 3 test devices, or am I an individual developer that's just working on a product? A few weeks ago, we launched our voice interoperability, so Dial SIM. This allows you to basically, any Twilio incoming phone number, you can just route the call directly down to the SIM. This is available in the US only right now. We will hopefully internationalize this very soon. And then also, we have in preview our programmable SMS functionality. So this allows you to, again, any message coming into an incoming phone number, route it straight to the SIM. And I should say for both of these, the really nifty thing is that actually you can intercept any outgoing communication from the SIM. So instead of having to use Twilio incoming phone numbers all the time, you can actually program any of the communications coming off the SIM, whether they're going to a Twilio number or not, whether they're just going to a regular number. I want to just walk you through a little bit of this functionality. So this is the Twilio Wireless console. You have your list of SIMs. There's various SIM states, which are described in our documentation. You can order SIMs, so that's what I was mentioning before. Go ahead and either order starter packs or just bulk SIMs. And you can also register a SIM. So registering a SIM is someone has given me a starter SIM that's not on an account already, and I'm just going to go through the process of actually assigning that to my account. You have your list of orders. You have your rate plans that I mentioned, and I can go ahead and create a new rate plan, for instance, and you see all of the functionality that I was mentioning. I can enable data, voice, messaging. I can choose that pooled versus individual metering. I can set my monthly limit. This is just a hard limit, so independent of however you're being pooled, this is kind of protection. This is actually enforced on the network, so you just basically, this is a sort of a way of preventing runaway billing. And then I can choose to nationally roam, which means to roam onto other carriers in the US. This is not used very often, but it is used in some rural settings. Or because I'm on the developer preview for global connectivity, I can also choose how I want to roam internationally in terms of data, voice, and messaging. And as I mentioned, voice is not there yet. I can go ahead and view my data usage. This is also available via API. And you'll see that in the last 30 days, I have been to 2 countries. I have been to the United States, where I used 2,719 megabytes. And this would, of course, change if I was to change this filter here as well. But I've also been to New Zealand. I spent 4 days in New Zealand 2 weeks ago. And I can go ahead and view that usage just in New Zealand. And actually, if I really narrow down, I can say on the 13th of May, obviously I was doing something at 8 in the morning and downloaded 800 megabytes of data in New Zealand. So that's pretty cool. You can also view your commands, which are those machine-to-machine SMS messages. You can see mine are really meaningful. And that's sort of the main functionality of the console. The other thing that you can do is if you want to view your SMS and voice traffic, you'll actually do that through the programmable SMS and the programmable voice products. I don't think I missed anything there. So let's talk a little bit about roadmap, and there's a little bit of history involved in that as well. So as we found out, a lot of you were here last year when we announced this partnership with T-Mobile for the US. The SIMs we're shipping today are US-homed SIMs. We do have that roaming agreement. They do work very well internationally, but they are US SIMs that we're shipping right now. We started shipping those SIMs in around about, this is a bit of an exaggeration, we started shipping August, September, and then really started to get some momentum around October in terms of shipping to preview customers. In Q1 of this year, we released self-service ordering, those per SIM data plans or the individual data plans that I mentioned. And we also released our blueprints, which Chaitan showed off in the keynote this morning, which is just educational content for building IoT devices. And then in the last few weeks here, we went into beta. We released voice and messaging in some capacity. We released the data and SMS usage reporting, so the graph that you just saw and the world map that you just saw. And then we also announced this global roaming. So that's basically brings us to today. The next major feature that we're working on is something that we think is really important for a lot of customers in production. and we're sort of growing up with you guys as you build your devices and get them ready for mass distribution, which is that you want all of your data running over a VPN. So we can do this from the network. You don't have to do this on the device. What this means is that you will establish a VPN to Twilio. You will buy an IP block of some size and magnitude, and then essentially all of your devices, IoT or not, will appear as if they are on your corporate network. So you'll be able to reach out to them using the private, using the static IP address essentially that now exists on the device, but also means you'll be able to route all that data traffic via your own servers. You can start doing intelligent stuff with it. You can start filtering. You can start enforcing rules. There's a whole bunch of interesting things you can do there. We're also going to be doing our what we call our rest of world SIM preview. So we are starting, in terms of starting to really think about global, we do have this US SIM. It does work very well. We are going to be releasing another SIM into preview, which is specifically targeted. It'll initially be sort of optimized for Europe, but it's what's, I don't want to get into too much details on how the SIM actually works, but this is a SIM that will be able to localize itself to a certain extent in different countries around the world, and it'll enable us as a company to go and do optimized operator agreements in different countries on the same SIM. The other thing we're doing in Q3 is something that you heard about in the keynote this morning, which is this feature we're calling Trust on Board. Trust on Board is actually really, really, really neat. There is a session on it this afternoon, which is being run by my colleague Jordan. I really encourage you to check it out. The reason I like it is it takes this thing, which is a SIM card, which is essentially a computer that's in all of your pockets that nobody has thought about since 1994 in terms of like what can we do with it that's really interesting. And we're providing mechanisms for you to use that to do TLS authentication against Amazon Web Services, against Twilio's own sync product, against your own servers. And it really solves this problem of how do you do diversification of identity at manufacturing time? And it solves it in a really, really, really simple, elegant way, and I really like it. So please go and check out that session. And then as we head towards the end of the year, I can't put any firm dates around this, but we want to really start thinking about localization. And what that means is the ability to target specific international markets without roaming. So if you have a very high volume use case, let's say you're automotive, and you say you have hundreds of thousands of devices using gigabytes and gigabytes of data, and you want to deploy in Australia, or you want to deploy in some particular country where roaming is probably not going to work either commercially or technically, we're going to have a suite of tools that allow you to control that. And that's sort of coming later this year. This is more, there are more commercial barriers to this than there are technical barriers. We already have a lot of the technical work done, so we're really just working through this. But you know, this is an optimization, I believe, in terms of this is not something that is very commonly done today. So this is an optimization. It's something that we want to really be a leader at. But I don't want to discourage anyone from thinking about what's possible today with those US SIMs in terms of their global connectivity. And that's it. We've got 3 minutes left. You can grab a free SIM if you want at the Programmable Wireless booth. I also have 3 starter packs right here, each which have 3 SIMs. The first 3 people to come and grab those can have those. If you want to email me, you can email ec@twilio.com. I'd love to hear what you're building, what you're thinking about, how we can support you, give you as much more detail as humanly possible. And yeah, please head on over to the booth and grab a SIM. We have tons. There's enough for everyone. And thank you for listening. Oh, one last thing. When you take your headphones off, don't put them on the back of the chair. Put them on the seat of the chair, because then the people will know to come and clean them for the next folks. Thank you.